Alright everybody, welcome back to the Introductory Astronomy Lab. This week we're going to go over Lab 6, or lens parameters. So the previous week we actually took the whole telescope, went out and observed the night sky. And we talked a little bit about what kind of lenses were in it and just the different components. This week we're going to go in depth with refraction and the actual different types of lenses that they use in telescopes. So to kind of give a brief overview of refraction, basically refraction is when you have a prism, right, just like that, and you have a light beam, a light ray coming in like that. The prism will bend the light and the different wavelengths will exit at different angles. And that is what produces the, I should say red, that nice prism spectrum that you see with the white light coming in and the different colors coming out. Now, similar to that, a refractor telescope, which we talked about last week, also does this. But it does it in a very specific way to produce a usable image. Now, we talked about the telescope design before, where we had the objective lens at the front. Now let's just take that objective lens out and kind of analyze it. And basically, if you were to take that objective lens out, you would have a convex lens, or a lens that kind of looks bowed out and then kind of pinches at the top and the bottom. So this is a convex or a positive lens. All right? And all the lenses we're going to be talking about in this case are thin lenses. And basically, a thin lens is just a lens that when light passes through it, for the most part, it's not going to produce any aberrations to the light. It's going to allow the light to pass through and will focus it or disperse it, but it's not going to distort the image, more or less. All right. So our convex or positive lens, when light, let's say a light ray is coming through here, or several light rays are coming through here. All right? The convex or positive lens, when they go through here, oops, that should be a little further back. Except if the light passes directly through the center, it's going to focus the light at a specific point, otherwise known as the focal point. All right? Now, if we go back to our telescope design, with the objective lens in the front, when you have your telescope, there's your lens, when the light comes in, at all different into the tube, it gets focused at a single point, at the focal point. And then goes out again and into the eyepiece for you to view. So that's basically a convex or positive lens and how they're used inside a telescope. Now the next part, or the next type of lens, and these are not used in a refracting telescope, but they are kind of used in a reflecting telescope. And these are concave or negative lenses. Okay, and basically they look kind of like an hourglass, or they're kind of pushed in the middle. And essentially, if you have light rays entering this concave lens, right, they enter like that, just like in the case of the convex. But instead of focusing at a single point, they're actually going to disperse the light, except if they go through the center. All right? So now an analog to this, while it isn't quite a lens, is in the reflector telescope. You have a concave mirror in the back. And basically, you have your reflector telescope, your eyepiece right here, your secondary mirror right there, light's gonna, and your concave mirror in the back. And mirrors and lenses function a little differently, but just to kind of go over it again, just because of the shape. The light's going to enter from all different directions, and it's basically going to reflect it to the centerpiece and out, or into the secondary mirror and out into the eyepiece, just like that. Okay, so for this lab, what we want to do is, we've gone over the lens properties. Now we want to actually see it in action. And this lab is actually one of my favorite labs in the course, because you get to actually see the physics in action. It's pretty easy to set up. It's not too bad. And you get to actually see the physics in action. So before we go over exactly what it's supposed to look like, we'll draw it on the board real fast. So essentially what you want to do is you want to have a laser, right? And in your lab kit you have a convex lens. You're going to have your lens here, just like this. So your lens will be here. And you're going to shine a laser beam through it. Now, if you pass the laser beam directly through the center of the lens, it'll travel straight on through. But if you take the laser beam and you move it side to side, the laser beam will, if it comes from here, it'll go like that. And if it comes from here, it'll go like that. And basically, you'll get, if you move it back and forth, you'll see it kind of change direction. And what you'll be able to do is trace out the laser and measure this distance right here and get your focal length. And even though it's not part of the lab, it's actually really neat. When you shine the laser, if you take your laser, let's say right here was where we had our experiment set up. And I actually have a laser pointer right here. And where is it? Okay. So if you take your laser pointer, you'll shine it through your lens, and you move it back and forth like this, you'll actually see the laser kind of move, the dot on the wall. It'll move back and forth and switch kind of the angle as you go. It's really very cool. So let's take a small break, and then we'll get it set up, and I'll show you how to actually do the lab. All right, everybody, so this is the basic setup for the lab. Essentially, you're going to need laser pointer that came with your lab kit, your convex or converging lens, and your lens holder, and a blank sheet of paper. You can use the graph paper that came with your kit, or I just have a piece of computer paper here. Either one will work, it'll be fine. The tricky part about this lab is that the laser, when you shine it or direct it, you can't see it in between. You can see the light, but when it hits something, but not as it travels over the paper. So what you have to do is get it just at the right height, and you'll have to adjust it, so that you can see the laser go across the paper and kind of move as you move it through the lens. Now, if you can get it to shine a straight line through the paper, and you may need help with this, you may want to draft somebody or ask somebody for help. What you want to do is essentially, when you can see the laser on the paper, you want to essentially trace out where the laser goes, right? So as you can see, it's kind of moving back. Let me just get it. It's moving back and forth. Ooh, there it is. It's moving back and forth through the lens. What you want to do is trace out those rays of the light. And where they intersect, that's going to be your focal length. All right, and we want to measure this distance and then complete the corresponding questions within the lab report. All right, so good luck, guys, and we'll see you in about a week for the next lab.